Alright, so now let's talk about one type of transformation, which is a translation, or also known as a shift. Translating is probably a more formal word for it. So we can translate our graphs either up or down by adding a constant, so that's a number, not a variable, to the function. And if we want to shift it left or right, we're going to add and subtract a number to x. Alright, so one main difference you might see here is that when you want to move the graph up, you add outside the function. And I'll show you what I mean. And if you want to go down, you subtract. Alright, that's pretty intuitive. Up, add, down, subtract. When it comes to shifting horizontally, left and right, your intuition might say, well, if I add, that's going to go to the right, because right on the x-axis is a positive direction. But that's actually not the case, and I'll show you why. Alright, but if you subtract something directly from x inside the function, whatever that may be, whether it's a parenthesis or a square root or an absolute value, if you do it inside of that directly to x and you subtract, it's going to move the graph to the right. Alright, and if you add directly to x, it's going to move it to the left. Alright, so let's look at vertical shifts right now first, and then we'll talk about horizontal shifts. Okay, so here on my TI Nspire, I have f of x equals x squared graphed in blue, and f of x equals x squared minus 2. Alright, now if we look, we see that if we trace the graph, we see the points on the blue graph are just, you take 0 and you square it, or you take 1 and you square it and get y, or you take 2 and you square it and you get y. Okay, you take 3, you square it, you get y. So the blue graph looks like that parent function, because it is, f of x equals x squared. Now the red graph, the only difference is you take all those y coordinates and you subtract 2. So if we look at these points together, the red graph, f of x equals x squared minus 2, always has a y coordinate 2 less than the blue graph. Alright, so see 1 to negative 1, 4 to 2, 3 to 7. Alright, and here's where I'm looking. If you missed that, I'm looking right here at the difference in the y coordinates. So by subtracting from the function, you're taking 2 away from all the y coordinates. So graphically, alright, if you think back to geometry, when you would subtract from x, it would shift the graph down. Alright, so that's why that works like that. And if I added 1 here, well, now it's going to move all our points up, because that's the rule in geometry. When you add 1 directly to y, it's going to translate everything up. Alright, now let's look at why subtracting from x moves the graph to the right. Okay, so now here I have in blue, I have f of x equals x squared graphed. Okay, and in red I have f of x equals x minus 1 quantity squared. So again, intuitively you would think if you subtract 1, it's going to move the red graph to the left of the blue graph, but it does not. It moves it to the right. And here's why. Alright, if we look at when we plug in 0 for x into f of x equals x squared, the blue graph, we get 0. Alright, we plug in 1, we get 1. We plug in 2, we get 2. We plug in 3, we get 9. Plug in 2, we get 4, sorry. That's because when you square those numbers, those are the y coordinates. Now, because we're subtracting 1 from x before we square it, okay, in order to get 0, so the minimum, so the vertex, you now have to plug in 1, which is 1 more than what you would plug into the blue graph. So you plug in 1, you subtract 1, and now it's 0 squared. So that's why these two boxes are the same, and that's why these two boxes are the same, because when you plug in 2 into the red graph, you subtract 1 first, and then you have to square it. Alright, so if I were to change this to like x minus 3 squared, well, now everything shifted to the right 3. Okay, if I were to change this to x plus 2 squared, now it shifted to the left 2, because why is it to the left 2? Well, I have to plug in negative 2 for x to get the minimum, to get the vertex 0. Whereas in the parent graph, I would just have to plug in 0 because I'm just squaring that. Now with the red graph, I have to plug in 2 less than what I would normally plug in to get the same y coordinate. So that's why it's kind of counterintuitive when you shift left and right. Alright, and here's another kind of explanation that I found online. So let's say we have a function y equals f of x, and then we add a positive constant to h. So what direction will it go? So if we add h directly to x, in the parent graph we have the initial point x comma 1 equals y1. But now, since we want to get the same y coordinate, we have to add x sub 1 minus h, so shifting it to the left, even though it's x plus h, in order to cancel out those h's to get the same y coordinate. So the point before the shift was x sub 1 y sub 1. Now it's going to be x sub 1 negative minus h comma y1, because that plus h is going to cancel out with that to give you that original y coordinate. Okay? So that's translating left and right.